Hello everyone, Bilkis here. Welcome back to my channel. If you are new here to my channel, I say a very big thank you and a very big welcome to this channel, because this channel is enlightening. You really do not want to miss any of my subsequent uploads. Alright, for those of you that are returning subscribers, I say a big thank you to all of you as well. If you haven't subscribed once again, please kindly hit the subscription button and hit the notification bell so that you get my uploads on daily basis. I upload videos Monday, Tuesday, Wednesday, Thursday and Friday, and they are usually very enlightening. All right, now the last class we did was we find common multiples actually. So today we are going to this one, we are going to be looking at the lowest or the least common multiples of numbers. They are different. Common multiples are different from what finding the lowest or the least common was multiples. All right, so what we are going to do now is this. Look at this example. For instance, we want to find the lowest common multiples of these following numbers. First of all, I want to find the lowest common multiples of 4, 5, and then 6. So what do? This is what we do. We bring out our 4, 5, and then 6. So you look at 4, 5, 6, and then you ask yourself, what number do you think can divide any one of them? Now that number you want to think of does not necessarily have to divide the 3 of them across, but at least it should divide 1 successfully among the 3 of them. So which one can I think of from the smallest, excluding 1, is what? 2. Now if I use 2 to divide, 2 will divide 4. How many 2 can I get in 4? Is what? 2. Can 2 divide 5? No. So that 5, I'm going to write it out the same way it is. Why? Because 2 cannot divide it successfully without any remainder. So I'll write out the 5 like that. Can 2 divide 6? Yes. How many times? 3 times. Now I have 2, 5, 3. What more can I use to divide that is going to divide any one of them successfully? It is still same 2. So I'll use 2. How many 2 can I get in 2? 1. Can 2 divide 5? No. So that means I'm going to write the 5 that way. Can 2 divide 3? No. So I'm going to write the 3 that way. Is that clear? Alright, now the next one is 1, 5, 3. What can I use to divide the 1, 5, 3? Since I have 1, 5, 3, and from the look of it, what else can I use to divide? Just 3. Just pick this lowest, the one that is apart from 1. Just pick the 3. Why? Because apart from 1, 3 seems to be the lower number which is there and can divide itself. So when I pick 3, this one still remains the same. And then 3 cannot divide 5. So I still write down my words, my 5. But 3 can divide 3 how many times? Just 1 time. Alright. So what do I have left? I have 1 and 5. And so that means I'm going to pick the 5 out of it. 5. Can 5 divide 1? It's still the same one I'm going to write. How many 5 can I get in 5? Just 1. And then this one. So the technique really, or the methodology really, is just the fact that as you divide below the tree, you continue to divide until you reach this point here where you have 1 all across. Does that make sense? So from here now, basically our lowest common multiple, therefore our LCM is now what? Is now 2 times 2 times 3 times 5. 2 to the power of what? 2, because I have 2 in 2 places. Multiply by 3, multiply by 5. And my answer is what? Now let's multiply through to see what we are going to arrive at. 2 to the power of 2 is what? 2 times 2, and that is what? 4. 4 times 3 is what? 12. 12 times 5 is what? 60. Hence, the LCM for 4, 5, 6 is what? Is 60. Now let's really move on to the next example. The next example is what? 6, 8, and 12. We want to find the LCM of 6, 8, and 12. We are going to use the same method anyway. So let's draw our tree or our table. It depends on what you want to call it. So when I look across the 6, 8, and 12, I ask myself, what number do I need to use that is going to divide at least 1 out of them? It doesn't have to divide everything successfully. So let me start with 2. If I'm starting with 2, now, how many 2 can I get in 6 is what? 3. How many 2 can I get in 8 is 4. How many 2 can I get in 12 is what? 6. So when I look across also, that means I can still use 2 because I have 4 and 6 there, which are divisible by what? 2. So I'll still use 2. 2 in 3 cannot divide 3 successfully, so I'll rather write the 3 like that. 2 in 4 is what? 2. And 2 in 6 is what? 3. So I have 3, 2, 3. Now from 3 to 3, I'll ask myself, what other number can I use to divide at least 1 of them successfully? It's still 2. Because I have 2 here. Now 2 in 3, it seems same 3. Because if I use 2 to divide 3, I'll have a remainder. So hence, I don't want to have a remainder. I'll rather write the 3 back that way. Now, how many 2 can I get in this 2 is 1. How many 2 can I get in 3? I'll write down the 3 like that because I don't want to have any fraction or any remainder. I don't want to have any fraction or any remainder, so to speak. Alright, now what do I have left? I have 3, 1, 3. Now, what other number can I think of to divide this 3 or this 3? 2 definitely cannot be the number, so I go for 3. Why do I have to go for 3? Because 3 is going to divide this one successfully. Does that make sense? Alright, so I'm going to use 3. How many 3 can I get in this 3 out is 1? How many 3 can I get in 1? The 1 is still going to remain. How many 3 can I get in 3 is what? 1. So you can see that when I got here, it's 1 all through. So the same way, you continue to divide down the table until you come across 1 all through here. Does that make sense? So therefore, the LCM for 6, 8, and 12 is going to be what? 2 times 2 times 2 times 3. And let's see what that gives us. The LCM will now be what? 2 into how many places now? 1, 2, 3. That's 2 to the power of 3 times what? 3. And that gives us what? Now this 2 into to the power of 3 means 2 times 2, 4. 4 times 2, 8. And 8 times 3 is what? 24. So now it is suffice to conclude that what? 24 is the LCM of 6, 8, and 12. Now let's look at 1 or 2 more examples under this topic. Now, we want to look at example 3 now. Example 3 also, we want to find the lowest common multiple or the LCM of 9, 12, and 15. Also, we want to find the LCM of 9, 10, 12, and what? 15. So we are basically going to use the same method that we used in the previous example here too. Alright, let's see how it goes. We have 9, 12, and 15 here. So just write it out. 9, 12, and then 15. So when I look at all of them, I'll start from the smallest number that can divide any of them. Not all of them, any of them. Take note, at least one of them. So if I look at, this is 9, this is 12, this is 15. 2 cannot divide 9, but it can divide 12. It cannot divide 15. So let me pick 2. Now, how many 2 can I get in 9? I'm going to have a remainder, and I do not want a remainder. So I'll rather write out the 9 that way. I'll not divide it. Because if I say 2 in 9, I'm going to have 4.5. That is 4.5, and I don't want that here. Alright, now go to 12. How many 2 can I get in 12? 6. How many 2 can I get in 15? I'll write out my 15 like that. Not that 2 cannot divide 15. It's going to divide 15, but it's going to leave us with a decimal fraction. It's going to leave us with a whole number and some number and another number that is not up to 1. So let me think of another number. I think 2 again can do the magic for 6. 2 can divide 6. 2 here, so I'm going to have my 9 again. 2 in 6 is 3. 2 in 15 is still what? 15. What else again? I can't use 2 again because 2 cannot divide this, cannot divide this, cannot divide this. So I'll rather use what? 3. In using 3 divide, how many 3 can I get in 9? Is what? 3. 3 divided by 3 is 1. 15 divided by 3 is what? 5. So I have 3, 1, 5. What else can I use? I can still use what? 3. When I have 3 here, I mean 3 divided by 3 is still what? 1. 1 divided by 3, I'll write just 1 because it's not possible. So I'll just write the 1 there. 5 divided by 3 will give me decimal. So I'll rather write the what? The 5. Does that make sense? So I have 1, 1, 5. What else do you think I can use? I'll just pick this 5 and use 5. Right. So when I have 5 here, so my 1 is going to remain. My other 1 is going to remain. But how many 5 can I get in 5? 1. So at this junction, I have arrived at 1 all through. That means I have to stop. Now my LCM is now going to be what? My LCM is going to be 2 to the power of 2 multiplied by 3 to the power of 2 multiplied by what? 5. 2 times 2, 4. 2 times 2, 4. 4 times 3, 12. 12 times 3, 36. 36 times 5. Let's see what 36 times 5 gives us. 36 times 5. 5 times 6 is 30. I have 3. 5 times 3 is 15 plus 3, that's 18. So I have 180. So the LCM for this is what? 180. Now let's look at the next example, which happens to be the last example of this lesson. Alright, we want to find the LCM of 9, 10, 12, and 15. So we are going to use the same method anyway. So I'll bring out my 9, my 10, my 12, and then the 15. Now what number comes to mind if I'm going to divide? I think I'm going to use 2 because I have 10 there and I have 2, which means 10 and 12 are divisible by 2. That is, 2 can divide 10 and what? 12. So I'm going to start from 2. So if I use 2, can 2 divide 9? yes, it will divide, but it will give me a decimal, and I don't want that. So my 9 is going to remain. How many 2 can I get in 10? 5. How many 2 can I get in 12? 6. How many 2 can I get in 15? I don't need the remainder, so my 15 is going to remain. Alright, when I look through, what else can I use? I can use 2. Why? Because 2 can divide 6 successfully. So I'll use 2 again. My 9 will remain. My 5 will remain. But how many 2 can I get in 6 is what? 3. How many 2 can I get in 15? It's still 15. Now when I look through, I cannot use 2 because 2 cannot divide this, and this, and this. So I'd rather use what? The next number, which is what? 3. How many 3 can I get in 9? 3. How many 3 can I get in 5? It's still 5. How many 3 can I get in 3? 1. How many 3 can I get in 15? 5. So I have 3, 5, 1, 5. I will still use 3 because I have 3 there. How many 3 can I get in 3? 1. How many 3 can I get in 5? It's still 5. How many 3 can I get in 1? I'm still going to write my 1. How many 3 can I get in 5? 5. Now, how many 3 can I get in 5 just simply means that if I use 3 to divide 5, I'm going to have a decimal fraction. And because we don't need a decimal here, we need all numbers. So my 5 is going to remain. Does that make sense? Alright. So now I have 1 and 5 here. What do I pick next? I'll pick 5. 1 divided by 5. Alright, my 1 is still going to remain. 5 divided by 5, 1. 1 divided by 5, my 1 is still going to remain. 5 divided by 5 is what? 1. Now, beneath here, I have 1 all through, meaning that I'll put a stop there. When you are doing lowest common multiple or least common multiple, the moment you arrive at 1 all through beneath the table, you just have to put a stop to it. Hence, the LCM of this 9, 10, 12, and 15 is going to be 2 to the power of 2, 3 to the power of 2, multiplied by 5. Does that make sense? Alright. So it's going to be 2 to the power of 2 times 3 to the power of 2 times 5. And let's see what that gives me anyway. So now the product is going to be 2 times 2, that is 4, times 3, 12, times 3, 36. And then 36 times 5, let's see what that gives. 36 times what? 5. 5 times 6 is 30, I have 3. 5 times 3 is 15 plus 3, that's 80. So also this one gives what? 180. So the LCM of this also is what? 180. Thank you so much for watching today's video. For those of you that have not subscribed, please quickly hit the subscription button and the bell beside the subscription button so that you can get notification every time I upload. Usually I upload tutorials Monday through Friday. Thank you so much for watching. And for those of you that still need more clarification, you can give me a message via the comment section. Like this video as many times like this video as much as you can, and then share this video with your loved ones. Thank you, and I'll see you in the next lesson.